Today we are going to learn how to find highest common factor, that is HCF, or GCD, that is greatest common divisor of two numbers or three numbers. So there are different methods to find. So first method is the listing method. The second method is prime factorization. Third method is common division, and the fourth method is long division. In this video I'll be covering listing method and prime factorization method. So let's begin with listing method. So before understanding listing method, we should know what are factors. Factors are numbers that can be multiplied to get another number, or they are exact divisors. For example, let's find the factors of number 6. So factors are those numbers which can divide the number 6 exactly without leaving a remainder. So 1, 2, 3 and 6. So let's take another example. Let's find the factors of 10. So the numbers which can exactly divide 10 are 1, then 2 can divide, 2 5s are 10, then 5 and 10 itself. So the factors are 1, 2, 5 and 10. So let's find the HCF of 15 and 20 by listing method. So let's take the first number, that is 15. Find all the factors or all the numbers which can exactly divide 15. So 1 can divide, 2 cannot divide 15, so we won't take 2. 3 can divide, 5 can divide, we cannot take 10, and the last number is 15 itself. Now find the factors of the number 20. So 1, again see 1 is a factor of every number. So 1, it's an even number, so 2. 3 cannot divide 20, 4 can divide, 5 can divide, 6, 7, 8, 9 they won't divide, then directly 10 and the last number 20. So 1 and the number itself are factors. So now let's identify common factors. So common factors of 15 and 20. So let's circle them. 1 is a common factor, then 5 is a common factor. That's it. So I'll write down common factors 1 and 5. The name itself says highest common factor. So between 1 and 5, 5 is the highest number or highest factor. So 5 is the HCF of 15 and 20. Let's take one more example. Let's find the HCF of 10 and 20. So I'll first write down all the factors of 10. So 1, 2, 5 and 10. For 20 the factors are 1, 2, 4, 5, 10 and 20. So let's highlight the common factors. So I'll write down common factors. So 1 is a common over here, 2 is common, 5 is also common, 10 is also common. So I'll just write it down. So 1, 2, 5 and 10, which is the highest common factor. So 10 is the highest common factor. So the HCF of 10 and 20 is 10. So let's move on to the next example. Let's find the HCF of 15 and 105 by listing method. So this method is not a listing method because we list all the factors. So let's find the factors of 15 first. So the factors of 15 are, so 1, 2 cannot divide this number, so 3, 5 and 15. Let's find for 105. 105, it can be divided by 1, you cannot divide it by 2, you can divide it by 3, then 4 you cannot divide, 5 you can divide, then 7 you can divide, then 21, 35 and 105, and one more 15 over here, 15. Okay, so now let's highlight the common factors. So 1 is common, 3 is common, then 5 is common, and then directly 15, because 15 sevens are 105. So now let's write down the common factor. So it's 1, 3, 5 and 15. Which is the highest common factor? 15 is the highest factor which is common in both the numbers. So the HCF of 15 and 105 is 15 itself. Okay, let's find the HCF of three numbers now. The method remains the same. Okay. So we have three numbers, 10, 25 and 30. So the first number is number 10. So let's find all the factors of the number 10. So 1, 2, 3 is not a factor, 4 is not a factor, 5 and directly 10. So 25. So 1 is a factor, 2 is not a factor, 3 cannot divide 25, directly 5, then directly 25. There is no number that can divide 25 exactly. 30. There will be many factors over here. So 1, 2, 3, not 4, 5, 6, 7, 8, 9, no, 10 directly, then 15 and 30. Let's circle the common factors. 1, then 2 is common, and 5 is common. After that there is nothing common. So there is 10 common in two numbers, but it has to be common in all the three numbers. So I'll just write down the common factors. So the common factors are 1, 2 and 5, and 5 is the highest common factor. So the HCF of 10, 25 and 30 is 5. So let's move on to the next example. Okay, so practice question. You need to find the HCF of 20 and 60 using the HCF, the listing method, and put the answer in the comment section. Let's move to the next method, that is the second method to find the HCF of two numbers. This is factorization method. So prime factorization method. So we will use prime numbers to find the HCF. So let's take the first number, that is 18. So you write down 18, draw one vertical line and horizontal line. Take the smallest prime number which will divide 18. So because it's an even number, we'll take the number 2. We'll start with number 2. 2 nines gives you 18. So now we have to take another prime number which will divide 9. So 2 cannot divide 9. So the smallest prime number which will divide 9 is 3. So 3 is 9. So I'll write 3 over here. Again I have to take 3. 3 ones is 3. So I'll write all the factors of 18 in product form, that is 2 into 3 into 3. The other number is 15. So I'll find all the factors, prime factors of 15. I cannot take 2 because it's an odd number, so I have to start with the number 3. 3 fives is 15. So I have to take the number 5 over here because 5 is a prime number. 5 ones. So I'll just write down the factors of 15. 15, 3 into 5. Now to find the HCF, the factor has to be common. So let's see which all factors are common in 18 and 15. So 2 is not common, 3 is common. So I'll just circle 3. There's nothing that is common apart from 3. So the HCF of 18 and 15, or 15 and 18 is 3. You don't have to multiply 3 and 3, you have to only count it as ones. Like 3 into 3 it's 9, but you don't have to take 3 into 3, it's only 3. So let's move on to the next example. Let's find the HCF of three numbers now. The method remains the same. We are going to find the HCF using prime factorization method. So the first number is 27. So let's find all the prime factors of 27. It's an odd number, so let's begin with 3. 3 nines is 27. 3 threes is 9. 3 ones is 3. So you have to stop as soon as you get 1. So let's write down all the factors of 27 in the product form, that is 3 into 3 into 3. Let's find the factors of 63. Again 63 is an odd number and you can divide easily with 3, so I'll start with the prime number, that is 3. 3 2s is 6, 3 1s is 3. Again I'll take 3, 3 7s is 21. 7 is the prime number, so I'll take 7 1s. So I'll write down all the factors of 63, that is 3 into 3 into 7. Let's take the last number, that is 54. 54 is an even number. I can divide easily with the smallest prime number, that is 2. 2 2s is 4 and 14, that is 7. Now I cannot divide by 2, so I have to take the next prime number, that is 3. 3 9s are 3 3s are 3 1s are. So I'll write down all the factors in the product form, 2 into 3 into 3 into 3. Next step is to circle all the common factors. Is 2 common in all the numbers? No. Okay, let's circle this 3 because this 3 is common in this number and this number. Is there anything else that's common? Yes, there is this 3 that is common. So you circle this number also. 3 is common in 2 numbers but not in the third one, that is 63. So let's write the final step. So HCF of 27, 63 and 54 is equal to, you have to only write the number once, whatever you have circled, that is 3 into, there's one more 3 that you have circled, so 3 into 3. The answer is 9. So the HCF is 9. So 9 is such a number which is common in 27, 63 and 54, and that is the highest number which is common in all the 3 numbers. Okay, let's find the HCF of 16, 32 and 48. So again 3 numbers, let's use the same method of prime factorization, that is 16. I'll start with 2, 2 8s are, 2 4s are, 2 2s are and 2 1s are. So I'll write down all the factors in the product form, that is 2 into 2 into 2 into 2. The next number is 32. So it's an even number, so let's begin with the smallest prime number, that is number 2. So 2 16s are, 2 8s are, 2 4s are, 2 2s are and 2 1s are. So I'll write down all the factors in the product form, that is 2 into 2 into 2 into 2 into 2. The last number is 48. Since it is an even number, I'll start with the smallest prime number, that is 2. So again 2 24s are, 2 12s are, 2 6s are, 2 3s are and 3 1s are. So write down all the factors of 48 in the product form, that is 2 into 2 into 2 into 2 into 3. Now circle whatever is common. So this 2 is common, so I'll circle this 2. Again this 2 is common, so I'll circle this 2. This 2 is also common, so I'll circle this 2. Yes, again this 2 is also common, so I'll circle this 2. Is there anything else that's common? No. So the HCF of 16, 32 and 48 is equal to, now whatever you have circled you have to write it only once. For example this 2 into, second thing that you have circled is again 2, third thing again 2 and again 2 over here. So 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16. So the HCF of 16, 32 and 48 is 16. Okay, so this is a question for you all. To find the HCF using prime factorization method, you need to find the HCF of 25 and 35, and whatever is your answer you put down in the comment section.